Hello everybody, thanks for inviting me back. We're going to look at another Hypatia question from the year 2004. We're on to Hypatia question number 3. So the question's getting a little difficult, ramping up to that question number 4, which should be quite hard, but that'll be another video. Okay? So hopefully you've given this one a bit of a go. It's got 2 parts, both of them involving these diagrams. And if you downloaded a copy like I did, I don't know, maybe they've updated it by now or something, but you download this, it's quite hard to read what's going on over here. I'm pretty sure that's C00, but I honestly can't tell. I think the questions clear it up. Yeah, so in the diagram, OMN has vertices 0, 0, 6, 0, and 0, 8, so we've got those here. So we can recreate the diagram, but you know, if they had just said the vertices are as shown in the picture, we'd have a bit of a problem. Okay. So in the diagram, triangle OMN has vertices 0, 0, 6, 0, and 0, 8. Already I'm starting to think right angle triangle 6 and 8 for side lengths. The distance between M and N has got to be 10. That's just stuff you pick up as you keep going along. So 6, 8, 10, great Pythagorean triple. Okay? Now we're being asked about P, the coordinates, determine the coordinates of point P. So they're saying A, B, so we'll probably use the A and the B in some equations. Inside the triangle, so that the areas of the triangles POM, PON, and PMN are all equal. Okay. What to do? I actually don't think we need the fact that it's a Pythagorean triple to help us out here. And I'll show you why. I'll draw this picture. Draw a picture here. Oops, wrong color. That's the navy blue. We don't want the navy blue. So we have N up here. I don't really care about his coordinates per se, but I can quite quickly see that we have length 6 here and 8 here. That's not so bad. So we have this point P in here. And we make triangles. We make 3 triangles. So using the 6 and the 8, I can do length times width times, or not length times width, base times height, 1/2 base times height, and get the area of OMN. So the area of OMN is 1/2 base times height. So this is 1/2 of 48, it's going to be 24. So we want each of these triangles to have the same area. So each of POM, PN, and PON must have area 8, because it's 24 divided into 3 equal parts, 3 equal triangles here. Okay. But if I look here, I've got 6 as the base of POM. But what is this altitude here? Why, it's just the y-coordinate, B. So B is an altitude of POM. So area of POM, I want that to be 8. As a formula, I've got 1/2 base times height. So that's 3b. So 3b must equal 8. B is going to have to be 8/3, or 2 2/3. We can do the exact same thing with A. The x-coordinate is just this distance, and it juts out perpendicularly. So similarly, 1/2 8a, which is really 4a, is the area of PON. And we need that to be 8 as well. So that's going to imply that A is equal to 2. Now, because each of these 2 triangles is now guaranteed to have area 8, PMN has to have area 8. That's the only amount that's left. So this quite quickly tells us the coordinates. So P has coordinates 2 and 8/3, or 2 and 2 2/3. Okay? But, no, not that bad. We didn't actually, I admit that I just sort of looked at that and said, oh, mn is going to be 10. Pythagorean triple didn't really matter. Did not matter at all. Didn't use that. Didn't even calculate anything for PMN. We were safe in the knowledge that that's got to be 8 because the other two were forced to be 8. Okay? So now we've got B part. So let's take a look here at B. In the diagram, quadrilateral. Okay, so they're sort of stepping things up, but I'm betting that it's still going to be sort of equal areas or something. So in the diagram, quadrilateral OMLK has 0, 0, 6, 0, 10T. That's over here. That is not clear what that is, but it is 10T according to the question. And K at 0T, so K is over here on the axis, he's up a height T. And T is going to be positive, we're told that. Show that there is no point Q inside the quadrilateral, so the areas of each of these triangles is equal. Interesting. No point Q that does this. Well, not only is this a quadrilateral, since both, what is that, K and L are at height T, this is actually, this is a trapezoid. So we can actually figure out this area in terms of T. Because it's got a base of 10, top part of 6, and T, so it should be 8T, I believe, is our total area. Each of these triangles would have to be 2T. As for showing that there's no point CD, what are we to do? Well, so with part A, what did we do? We worked out A and B completely independent of one another. So maybe there's a way to maybe we should work out C and D independent of one another, or I'm going to draw the picture. I think I see where we should be going with this. I'll draw the picture not only because I want to step it up, but I also want a picture I can read without having to struggle. So K is up here at 0T. We go all the way across to 10T, and that's L. We come back a little bit. Here's M, and that's at 6, 0. And we've got O over here at 0, 0. Okay. So we have this point Q in here, and I'm going to use a different color to draw my triangles. So there should be no point Q that does this. Okay. Now, it's going to be quite hard to deal with things like QLM, because he's a slanty little triangle. QOK, that one certainly can deal with him. And then LK is parallel to the x-axis, so we get a right angle here, and we get a right angle here. Now this is going to be the height of Q, so he's going to be D, and this guy's going to have to be T minus D. And I wonder if there's a way to sort of work those guys out. Okay, so the area of QKL must be, area must be equal to the area of triangle QOM, COM. And we have calculations for those in terms of T and D. So, QKL, that's going to be base of 10, so 1/2 base, and the height there is T minus D. And then we have a base here of 6, so 1/2 6D. So we get 5T minus 5D has got to be equal to 3D. So 5T is going to be equal to 8D. Interesting. Don't know where that gets us right now, but 5T is 8D. So is there some reason that this is an impossibility? Well, if this is 5t, as I mentioned, I think I can get this, so OMLK is a trapezoid, since KL is parallel to OM. So the area of OMLK is 1/2 the 10 plus the 6 times the height. So it's going to be 8t. Now, t is 8 over 5d. So that's going to be 64 over 5d. And so we're splitting this guy into fourths. Each of these needs to have equal area. So if each triangle has equal area, they have area 1/4 of this 64/5 d, which is really 16/5 d. All right. So now that tells me that triangle, what was it? QOM, which has area, it was 3D, must also have area 16/5 d. This is impossible. I didn't actually think it would be that quick, and we had nothing to do with C there. Is that really all it is? So it should be 3D if you calculate it this way. But in terms of total area, it should be 16/5 d. And those two numbers are not the same. It's very close. If it was 15 over 5d, we'd be all set. But sadly, it's just not enough. Actually, no, it's too much. It's more than 3d. So no such Q can exist. Okay, not so bad. It's not a bad question. It didn't take me as long as I thought it would. I expect 3 on a Hypatia to take me a little while, and I'd say this one was kind of straightforward. I don't really have a whole lot to say there. I suppose if you want to be super rigorous, you probably should have started the proof that I gave by saying, suppose such a Q did exist. But really, all the highlights are there, so I'd say that's worth full marks. And yeah, nothing else to say there. It was a really quick 3 in my opinion. Hopefully 4 will provide a bit more of a challenge, and we'll be taking a look at that one in the next video.